This is the leXsolar Wind Ready to Go, our fully equipped experiment system for the basics of wind energy. The system is supplied in a sturdy aluminium case with foam inserts, and all necessary accessories such as cables and motors are included. In the following experiment, we now want to compare a conventional wind turbine with a so-called Savonius rotor. For this, we need the leXsolar base unit to which the individual modules are plugged. We also need the wind turbine with the optimized blades and the associated module. The Savonius rotor is also used as the wind machine and the meter. We have now collected all the components for the trial and can start assembling. First, we want to build the wind turbine. We use 3 optimized rotor blades and the associated hub and cap. The rotor blades are put with the rounded side up into the recesses in the hub. Subsequently, the cap is placed easily and firmly. Our wind rotor is now finished. The wind rotor is now connected to the turbine and attached to its module. The finished wind turbine module is then plugged into the base unit. For the experiment, we need wind, which is supplied by the wind machine. The direction of the wind machine is characterized by printed arrows. The wind machine will be electrically connected to the jacks on the bottom. Take care with the correct polarity. A switch allows convenient switching on and off of the air supply. The wind machine is then plugged into the base unit. Since we want to perform a quantitative test, now only the meter is missing. The cables are attached to the base unit and electrically connected to the measuring device. The trial is now set up and ready for the meter, which is electrically wired. That means the only thing missing is the wind supply. We turn on the wind machine and see how the wind rotor begins to rotate. Thereby, the voltage on the meter begins to increase. With our classic wind turbine in this structure, we can now generate a voltage of 5 volts. Now we turn off the wind machine and see how the rotor slows down and the voltage decreases. When the wind rotor has stopped, we can remove the wind turbine. We replace them now against the Savonius rotor, which is also attached to the base unit. We now turn on the wind machine again and see what happens. With the naked eye, it's identified that the rotational speed of the Savonius rotor is much slower due to the greater inertia than the classic wind turbine. Due to this fact, the achievable voltage by the Savonius rotor is significantly lower than that of the voltage by the conventional wind turbine. The 5 volts from the previous attempt is not reached anywhere near once. Despite all, the Savonius rotor is used because of the independence of the wind direction in some areas. Even with the Savonius rotor, the voltage drops when you turn the wind machine continuously rather than abruptly. Using the experimental system, many more experiments are possible. For example, qualitative tests with horns or motor engine modules or the attached LED. With the aid of the potentiometer module, an IV characteristic can be received. The wind rotor can be varied by the shape of the blade, the pitch angle, or the number of blades. We have just experienced the Savonius rotor in the experiment. To measure the wind speed, an anemometer with associated base is in the case. All necessary accessories such as cables and meters are faithfully included in the ready-to-go philosophy. The accompanying CD contains all instructions and detailed background information. Further attempts are made possible by a capacitor module, resistors, or light bulb module. We wish you lots of fun experimenting.